What's going on, guys? So in this video, I'm going to show you guys how we can set up a workflow for developing Node.js and Express apps within a Docker container. So the first thing that I want to do is I want to set up a quick and simple Express app that we can use for demonstration purposes. And the reason why I didn't actually prepare the Express app ahead of time is, first of all, this is going to be the quickest and simplest of apps. We'll be able to knock it out within like a minute. But I want you guys to focus on these steps that we need to actually create this app, because they're kind of important, because we're going to recreate those steps within the Docker container as well. So I've got my project directory. I called it Node Docker already here, and I've got it open up in VS Code. So, with any other Express app, the first thing that we have to do is get our package.json file. So I'm going to do an npm init. Right, and that's going to create our package.json. And since we are creating an Express app, we're going to have to install Express. I'm going to do an npm install Express. So now we've got our dependency. The next thing that I want to do is also focus on the fact that we did create our node modules folder. So that happened when we installed Express. And the final thing that we need to do is actually create our application. So I'm going to create an index.js file. And I'm going to import our Express. So we'll do const express require Express. And then we can do const app equals Express. Right, then I'm going to specify the port that I want my Express server to live on. So I'm going to do const port. So this variable is going to represent the port that it's going to be listening on. And I'm going to set it equal to process.env.port pipe 3000. Right, so if you don't know what this line is, it's basically saying that if the environment variable called port has been set, we're going to set this variable to that value. However, if it's not set, we're going to default to a value of 3000, usually common configuration. And then we can do an app.listen, and we'll listen on that port. And when our server comes up, we can say console.log, listening on port, and then we'll pass in that variable. All right, so now the last thing that I want to do is set up a quick route for testing purposes. So I'm going to do app.get. And we'll just say the root path, and then we'll do rec res. And so if anyone sends a GET request to this path, we're just going to send back a simple response, which is going to be, we'll just send an H2 that says hi there. And I forgot the comma right here. All right. And so that's our entire Express app. I'm going to start this app real quick. So we're going to do node and then index.js. And it looks like I forgot to save, probably. All right, so it looks like I already had another Express app listening on port 3000. So I deleted that. So now if we do a node index.js, it should start. It's going to be listening on port 3000. We can go to our web browser real quick, and we can just go to localhost :3000. And when we do that, we should see it say hi there. I'll zoom in for you guys so that you can see that. And so that confirms our Express app works. So we've got our dummy Express app. So now we can go ahead and get started with actually integrating our Express app into a Docker container and setting up a workflow so that we can move to developing our application exclusively within the Docker container instead of developing it on our local machine like we just did. So now that we got our Express application complete, or the demo Express application, let's work on setting up our Docker container. Now for this video, I'm going to assume that you already have Docker installed on your local machine. If you don't, go ahead and do that now. Just follow the instructions on their website. It's fairly straightforward. Just make sure you follow the directions for your respective operating system. But once you have Docker installed on your machine, head on over to hub.docker.com. And I want you to just search for Node within that search bar right there. Once that's finished loading, you'll see that the first result is the official Node Docker image. So this is a public image provided by the Node team. And it's a fairly lightweight image that basically has Node already installed for us so that we don't have to do this ourselves. And if you take a look at the documentation, you'll see that we've got all of the various different versions that it supports. So you can get version 15, version 14, all the way back down to version 10 if you really want. And it's got directions for this image or any specific things that are relevant to this image when you want to deploy a container from it. Now, this Docker image right here is not going to have everything that we ultimately need for our application, because the whole idea behind Docker and an image is that the image is going to have every single thing that's needed for your application to work. And so for our application, we obviously need to get our source code into the image, and we also need to get all of our dependencies like Express, any other dependencies that our application may need. So to do that, what we're going to do is we're going to create our own custom image, and we're going to base this custom image off of this Node image. So we're going to take this Node image, we're going to copy all of our source code into that Node image, and then we're going to install all of our dependencies like Express. And then that final image is going to have everything that we need to ultimately run our application. So let's get started on doing that now. Okay, so let's get started on creating our own custom image. To create a custom image, we need to create a Dockerfile. So the Dockerfile is just going to be a set of instructions that Docker is going to run to create our very own customized image. So let's create a new file, and we're going to call this Dockerfile with a capital D. Now in our Dockerfile, it's going to have a set of commands that Docker is going to run to create our own personalized image. And the first command that we always have to do is we have to specify a base image. So when you create a custom image, what you're ultimately doing is you take a base image or a known image of some sort, doesn't matter where the image is from. It can come from your own Docker repository. It can come from Docker Hub. It can come from anywhere. You just need an image that Docker has access to. And we're just going to tweak it a little bit so that it contains all of our source code. It contains all of our dependencies and things like that. So in this case, we already found our base image. It's going to be this Node image because that's really the only thing that we need to run, right? We just need it to have Node and anything else to run Node. So we're going to take this as our base image. And the instructions here is going to show you how we can ultimately use that. So here you just specify Node, and then you can do colon and then the specific version you want. If you don't specify the version, I forget what version it grabs, but if you read the instructions, it's probably going to say it grabs like version 14 or something like that, or maybe the latest version. Right, so what we do is we do from, and we'll capitalize from, and then we say Node because that's the name of that image or our base image. And then we can do colon and then the version we want. So I'm going to specify version 15. Not that we need version 15. We can run 14 or really any version. We're not doing anything specific to any new versions. I just want to show you guys how to actually specify a version. So that's something that's absolutely needed. The next command is technically optional, but it's still recommended. And that's called the workdir command. And I'm going to set that to /app. So what this command does is it sets our working directory of our container to be the /app directory within the container. So I know this /app directory exists in the container because I've run the Node image and I know it's got a /app directory. But setting the work directory is really helpful because anytime you run a command, when you set the work directory, it's going to run that command from this directory. So we can put all of our application code in /app, and we can run node index.js on /app. And it's going to run it automatically in /app without us having to specify. So the working directory just is the directory where you run all your commands, and it's also the directory where if you copy any files to your container, it's going to by default send it to this directory. So this is just recommended, but it's not technically necessary. Now the next thing we want to do is we want to copy our package.json file, which is this file, which contains all of our dependencies and anything else that we need. And we're going to copy it into our Docker image. So let's go to, so we can run the copy command. And so we copy the path to the package.json file, which is our current directory. So we just do package.json. And then we have to specify the directory we want to copy it to in our image. And so I'm going to do this dot, which means the current directory. And the reason why I do that is because we set our working directory up here to be /app. So when you do dot, it's going to assume the /app directory. We could technically also just do /app, same result, but since we have the working directory set, we can just specify it relative to that directory. The next thing is, once we have our package.json, remember it's got a list of all of our dependencies. We want to actually install our dependencies. So we want to run an npm install. So in our Dockerfile, to run a command, we can do run, and we can do npm install. Right, so we now have our package.json file copied over, and then we run npm install. Now we've got Express installed for us. The next thing we want to do is, and this part's going to be a little bit confusing, but we're going to copy the rest of our files. So all of our source code, everything else, into our Docker image. So we'll do a copy again. And here, instead of specifying a specific file, I'm just going to say the current directory. So this is going to grab every single file, every single folder within our current directory. And we're going to copy it to, just like we did here where we just did a dot, which is going to send it to the slash app. We're going to do the same thing. So we can just do dot or dot slash, same thing. And right here, you might be a little confused. You might be wondering, well, why do we copy the package.json first and then copy all of the files over? Do we even need this step before? If we're going to copy all of our files, this should copy our package.json, and it does. The reason why I split it up into two different steps is a little bit of an optimization technique. So let me explain how Docker images actually work. When you create an image from a Docker file, it takes each one of these steps and it treats it as a layer of the image. So you could think of an image as just basically these 5 steps or 5 layers. So once you build all 5 layers, you have the ultimate image or the final image. So this first command creates one layer of the image. This second command creates another layer of the image. This third command creates the third layer, the fourth layer, and the fifth layer. And they all kind of build on top of each other. And what's important is that after each layer, the Docker actually caches the result of each layer. And what I mean by that is when we run Docker build, when we actually build our image for the first time, what's going to happen is that it's going to run this first step and it's going to cache the result. So it's going to say, hey, look, we downloaded the node image from Docker Hub, and then we cache that result, right? We then set the working directory to /app, and we cache the result of that. We then copy package.json, we cache the result. We then npm install, cache that result, and then we copy all of our code and we cache that result. And this is important because let's say we decide to rebuild the image again, right? If nothing changes, Docker is efficient. It knows that nothing's changed in any of these layers, and it just takes the final cache result of step 5, which is the last layer, and it just gives that to you. So if you run Docker build, which is the command to actually create the image, the first time you run it, it's going to take a long time because it's got to run all of these steps. And especially the npm install, if you have a lot of dependencies, it's going to take quite a while. But the second time you run it, if nothing's changed, you'll see it'll be done in less than a second. And that's because it's cached all of the results. And the reason this is important, and the reason why I split this up into 2 different steps is, I want you to think about what happens during our development process, right? When we are actively working on our code, what changes? Our package.json does not change very often, right? I mean, we do occasionally add new dependencies. That's normal, but it's, for the most part, your source code changes, but your package.json and your dependencies don't change very frequently. And so by splitting this up into 2 different steps, what happens is we cache each of these layers, right? And so we're going to cache the node image, we're going to cache the working directory, and in reality, those 2 will never change, right? We're never really going to change those 2. So we're always going to essentially cache the result from step 2 and onwards. But the thing about Docker is, if any layer changes, right, say that layer 3 changes, and what I mean by layer 3 changes is that if package.json ultimately changes, where maybe we add a new dependency, we have to rerun step 3 and all of the steps after that, because we don't know how that's going to impact step 4. We don't know how it's going to impact step 5. And so by caching, by splitting these up into 2 different steps, we can say that, listen, if package.json never changes, then we're going to cache that result. And since realistically, when we're actually programming, package.json is just not going to change. So we're going to cache that result. And since package.json is cached, then we're going to also cache the result of npm install because nothing's really changing. So we cache those results. And so when we change any of our source code within our application, the only step that really changes is layer 5, where we copy the rest of our code. And so we only need to rerun step 5. However, if we didn't have this split up into 2 different steps where we have a copy package.json and then copying the rest of our files, what would happen is that anytime we changed our source code, technically it would rerun everything, including the npm install, because it doesn't know that we only changed our source code. It just sees that, listen, this step where we copy all of our files has changed. We're going to have to rerun all of the steps after that. So by doing this, we know that package.json will always be the same. So we can cache the result of these 2 steps and only run step 5, which is the changing of our source code. So it's a little bit of an optimization. If it didn't make sense, I don't think I did that great of a job of explaining it. But I'll show you guys this when we actually build our containers, how it actually caches the results of each step and how it's a little bit of an optimization to actually do this and split this up into 2 different steps. All right, so the next thing that we want to do is we know our application is going to be listening on port 3000. So let's do expose. So we're going to say our container is going to expose port 3000. And then finally, when we start our container, we want to tell it what command to run. Right? And since this is a Node application and our entry point into our Node application is this index.js, we have to tell it to run index.js. So we do cmd brackets, and then we're going to do node and then index.js. All right, so when we deploy our container, it's going to run in index.js. So this is at runtime, and this is at build time. So hopefully you guys understand that. So this is when we're building the image. This is the command that's going to be assigned to the container when we actually run the container. And so that's all we really need. We're going to go ahead and actually create our image now. So let's go to our terminal down here, and I'm going to stop our Express server because remember, we're no longer going to be developing on our local machine. We're going to be developing on the Docker container. So make sure you stop your local instance of your application. All right, and let's build our Docker container. Oh, sorry, our Docker image. We're building the image right now, not the container itself. So we'll do a Docker build. And then we're going to specify the path to our Dockerfile. It's actually called the context. It's not necessarily the path to the file. It has a little bit more of a meaning to it, but I don't want to spend too much time going on it. Just think about it as the path to the Dockerfile. So this Dockerfile is in the current directory, so we're just going to do a dot. So let's run that. And I realized I forgot to save my file, so let's save that. And I'm going to rerun that. And I want you to pay attention to the output. Notice what's happened. And I think this is kind of important when you're trying to understand what's happening. You can see that on step 1 of 5, it says we're going to grab the node image from docker.io. So it's pulling the image from the from Docker Hub, right? And as I said, each one of these is a separate step or a separate layer, right? And if we go down, we go to step 2, and it says working directory is set to /app. You can see that it says cached. So you're not going to see it say cached on your machine. That's because I ran this as practice before I recorded this video. But it's not going to say that it's cached when you ultimately run this. So keep that in mind. But if you run this again, right, what should happen is that it should cache all of the results, right? And so now all the way down to step 5, it's cached. So if you run it again, like I said, there's an optimization where it actually caches the results. And the second time you run it, it's going to be much, much faster. So now what we're going to do is we're going to do a Docker image ls, and you can see the new image it created. This is the one without a name because we didn't specify a name. You also see the node image that it pulled from Docker Hub, which is node 15. Now, I don't like the fact that we didn't give this a name. So let's do a Docker image rm. This is going to delete the image that we just created. And I'm going to pass in that image ID. And if we do a Docker image ls, you can see that it's gone now. So now we're going to go back to the Docker build command that we ran, but this time we're going to pass in a specific flag. So we'll pass in the -t flag. So here we can give it a name. I'm going to call this node-app-image. All right. So once that's complete, we'll do a Docker image ls. And now you can see we've got our image that we just created. So now that we have our image, let's go ahead and run it and let's test it out, see if everything works. So we'll do a Docker run, and we'll do node-app-image. So here we're just specifying the image that we want to create a container from, which is this image that we just created. But before you hit enter, there's a couple of flags that we got to pass. So first of all, I want to give my Docker container a name so that I have some kind of way to identify it. So we can pass in the -name option, and we'll call this node app. So keep in mind that last entry in my command is the name of the image that we're creating a container from. This is the name of the container that we're creating. And then finally, there's one more flag I want to pass, which is -d. So that means it's going to run in detached mode because by default, when you create a Docker container from Docker run, you're going to be attached to the CLI or the console or whatever it's called. But here I can run it in detached mode so that my command line's still free and open. So let's hit enter. And it looks like it's successfully created my container. I can do a Docker PS. And we should see that there's a container open at the moment. All right, so let's test this out. And what I'm going to do is let's just go to my localhost :3000, hit refresh, and let's see what happens. All right, so it doesn't look good. It's spinning, which most likely means there's something broken, and it looks like there is. Don't worry, guys. I know exactly what's wrong. I purposely did this. So let's tackle exactly what's wrong with our Docker container in the next section. So we were unable to connect to our Docker container on localhost :3000. Now, why exactly were we unable to do that? Well, let's take a look at our Dockerfile. And if we go back here, we can see that we do have this command expose 3000. And I think naturally most of us would assume, hey, look, we're exposing port 3000, so we should be able to access that. Well, not exactly. This line does absolutely nothing. This is really more for documentation purposes. If you delete this command and create a brand new image, it will not impact our image or container at all in any way, shape, or form. It's just so that when you share your Dockerfile with someone else, they'll know, hey, look, this image expects you to open up port 3000 for everything to work. So this line doesn't actually open up port 3000. And the thing about Docker containers is, by default, they can talk to the outside world. So if a Docker container wants to reach out to the internet or wants to reach out to any other devices in your host network, it can do that. However, outside devices like the internet or your host machine or any other machine from the outside world, by default, cannot talk to a Docker container. This is almost like a built-in security mechanism, right? You don't want the outside world to be able to access your Docker container, but your Docker container can access them. So how do we make it so that the outside world can talk to our Docker container? And keep in mind, when I say outside world, I don't just mean the internet, I also mean our local host machine, right? And when I say local host machine, I mean my Windows machine right here, right? To actually talk to the container from my computer, which is kind of seen as like an outside device, we have to poke a hole in our host machine. And what I mean by that is that by default, right, our Docker container, nothing from the outside world can talk to our Docker container. So we have to basically say on our host machine, hey, if we receive traffic on a specific port, we want to forward that traffic to our Docker container. And the way we do that is, it's very easy. First of all, let's kill our container. We don't need that anymore. So I'm going to do a docker rm and then specify the name of our container. So we'll do node-app. And then I'm going to pass in the -f flag. So this stands for force. So by default, usually you have to stop a container before you can delete it. If you pass the -f flag, it'll allow you to delete a running container. All right, so now if I do a docker ps, we should see an empty list. So let's do docker, let's rerun that command. But here I'm going to pass in another flag. I'm going to pass in the -p flag. I'm going to specify this. So let me explain what this is in a second. So we've got port 3000 and then :3000. So what exactly does this mean? We've got two different numbers. We've got the 3000 to the left of the colon and 3000 to the right of the colon. So the number to the right, let's start off with this one, is the basically the port that we're going to send traffic to on our container. And our container, remember our application's listening on port 3000, so we want to send this to port 3000. Right? If this was set to 2000, then we would want to set this to 2000. So whatever our container is expecting traffic on, the number to the right of the colon should be set to that value. Now the number to the left represents traffic that's going to be basically coming in from the outside world. So if another device on your network or even your local host machine, right, my Windows machine, if we send traffic to localhost port 3000, right, we're going to take traffic that's coming in on port 3000 and sending it to port 3000 on our container. But in this case, even though the two numbers are the same, they don't have to be. So let's say we wanted to basically poke a hole so that anybody that sends traffic to our Windows host machine here on port 4000, we should then forward it to our Docker container. In that case, we would change this to a 4000 and we would keep this to port 3000 because remember, it's still listening on port 3000. However, if this was 2000, then we would change this number to be 2000 here, right? So hopefully that makes sense. I've set up a little quick diagram. I don't know if you guys understood it at this point, but hopefully the diagram makes it a little bit easier to understand. So let me pull that up. So here in this diagram, I've got my host machine, right? Which is this big blue box, which is my Windows machine. And then I've got this node container in green right here. And so what's going to happen is, we've got those two numbers, right? Basically what we want to do is when our host machine, right, our Windows machine receives traffic on port 3000, what we want to do is we want to take that and forward it to port 3000 on our node container. So that's why we have 3000 colon 3000. So the first 3000 represents the red arrow, and then the second 3000 represents the yellow arrow. And this also applies when we send traffic from our host machine to the local host IP, so to ourselves. So if we send traffic to localhost port 3000, it's going to take that traffic and it's going to forward it to port 3000. And once again, like I said before, we don't have to do 3000 to 3000. We could change this to 4000, and then we would send traffic to localhost 4000, and it would forward it to traffic on port 3000 on our node container, because once again, our node container is listening on port 3000 because that's what our Express server is listening on. All right, so hopefully that made sense. I'm going to run my container now. So I'll hit enter. And I changed everything back to 3000 colon 3000 because that's just a little bit simpler. Why not have both of those numbers match? There's no need to unnecessarily complicate things. Let's do a Docker PS. All right, and you'll see that we've got our container, but under this port section, you can see that it looks a little different. You can see that right here, we've got basically 0.0.0.0 on port 3000 with an arrow to 3000/TCP. So what this is saying is any traffic destined to your host machine for my Windows machine right here on port 3000 is going to get forwarded to port 3000 on my container. So now let's go back to their webpage and let's do a refresh. And you can see now it says hi there. So we have successfully sent a request to our Docker container on port 3000. Now, before proceeding any further, I do want to show you one thing real quick. Let's actually log into our Docker container and take a look at the files in there. So we can do that by typing in docker exec -IT for interactive mode, and then we'll specify the name of our Docker container, which is node-app. And then we want to pass in a new command instead of the usual node index.js. We're going to pass in bash. So this is going to allow us to take a look at the file system of our container. So here, by default, it's going to drop us in the /app directory just because we set the working directory to be that. And here, I just want to type in an ls. So this is going to list all the files in that directory. And so you're going to see all the files that are copied over. So we've got our package.json, we've got the package.lock, we've got the node modules folder, our index.js, and we've got the Dockerfile. And the reason why I wanted to show you the file system is you may be wondering, what is our Dockerfile ultimately doing in our Docker container? Right, our Dockerfile is there to create an image, but we don't actually need it in our Docker container. And I also wanted to point out one more thing. If you take a look at this copy command right here, what it does is it copies everything in our current directory, so every single file, and it copies it into our container or our image. And this is a bad thing because there are going to be files that you don't actually want copied into your container, right? Just like our Docker file that I mentioned, we may also have an environment file that has a lot of our secrets that we don't actually want copied into our container, potentially. Also on top of that, we don't need to copy our node modules folder. This is actually a waste of time because a lot of times this folder is actually fairly large, and we don't need to do that because remember, we're copying our package.json file and then we're doing an npm install. So there is zero reason to ever have to copy this node modules folder into our container. And on top of that, we ultimately want to move away from developing on our local machine. So moving forward, we won't even have a node modules folder on our local machine. It'll only ever exist within our Docker container. So why are we even copying it in the first place? It could be stale. We may not even have it. So we need to find a way to make it so that Docker does not copy over files that we don't ultimately want copied over. Just like this Docker file, just like the node modules folder. If we have Git configured, we definitely don't want that copied over. And so we can do that by creating a Dockerignore file, right? And that probably sounds a little familiar because if you work with Git, Git has a gitignore file for files that you don't want checked into your Git repository. Same exact concept. So let me exit out of my container. So we can do exit to exit out of the file system. And I'm going to kill that container. So we'll do docker rm node-app, and then we'll do -f for force. And let's create a Dockerignore file. So I'll do a new file. And I'm going to call this dot or period, and then Dockerignore. And within our Dockerignore file, we're going to list out every single file and folder that we don't ever want copied into our Docker container. So the first thing is we don't want to copy our node modules folder because we're going to do an npm install from our package.json anyways. There's really no need to ever copy it over. We don't want to copy over our Docker file. Now that we have a Dockerignore file, there's really no need to copy that into our Docker container. And then a few other things, right? If you have Git, you don't want to copy Git. You don't want to copy your Git ignore. For now, I think that's good. You'll see later on in the video, we'll add a couple more files, but for now, that's okay. Just do a save. And now let's rebuild our image. So let's find that build command. So docker build -t, the name, and then the path to the Docker file. So that's their current directory. So we'll run that. Let me just make sure I didn't change anything in my index.js. Yep, everything looks good. So let's run that. All right, so that's done. Let's run our container from the new Docker image that we just created. So if we hit up for that Docker run command, let's see if I can find it. Here we go. So Docker run -p. So we're going to open up port 3000, run in detached mode. We're going to give the container a name of node-app, and we're going to use the node app image that we just created. All right, so we did that. Let me just quickly double check to make sure I didn't break anything. So we'll hit refresh. It looks like everything's working. Perfect. Now let's go into our Docker container again. So we can run that docker exec command. And let's just make sure it didn't copy over any unnecessary files. So let's do an ls. And now it's perfect, right? We no longer see a Docker file. There's no Dockerignore file. I can't verify for you guys that we didn't copy over the node modules folder, but just trust me, this node modules folder is from running an npm install on the 4th step, and not because we copied it over from our local machine. All right, so let's exit out of that. Okay, so now that we got our application working in a Docker container and we can access it from our local machine, let's see what happens when we change our code. I'm going to go back to my my index.js file, and I'm going to just tweak something. Right here it says we're sending an H that says hi there. I'm just going to add a couple of exclamation points. We'll save that. And I'm going to minimize this, and let's hit refresh. Let's see what happens. We hit refresh. Nothing happens. We don't see the exclamation points. So for some reason, our code didn't get updated. And I want you to think about why that is. It's actually a really simple answer, right? Basically what happens is, first of all, we have to take our Docker file, we have to build an image. So we built an image, and then we built a container from it. Now we changed our code to add the exclamation points, but our image that we created from our Docker file was run before we made these changes. So the code in that image does not have the exclamation points. And so basically our image has a stale version of our code, which means our container, which is running from that image, has a stale version of our code. And we can prove that. If we do a docker exec and go into our code, if I do an ls, we can see our index.js file, and I do a cat, which is just going to print the contents of that file. If I do an index.js, you could see that there's no exclamation point. So it's running a stale version of the code. So how do we actually update that? Well, it's actually very simple. First of all, make sure you save all your changes. And now what we're going to do is we're going to rebuild that image. Well, first of all, let's delete our container. We don't need it anymore. And let's rebuild the image. So where's that build command? So build. Right. So now if you take a look, you'll see that because our source code changed, it had to run step 5 once again. So now if we do a docker image ls, this new image, which we named it as the same name as we had before, now has the new exclamation points built into the image. So if we deploy this image with a docker run command, it's the same exact docker run command, hit enter. And now if we go back to our web browser, hit refresh, we can now see the exclamation points. So that explains why our code didn't automatically get updated. However, I'm sure you're thinking, well, this is kind of a strenuous process for when you update your code, right? Every time I make a change, I don't want to have to rebuild an image and redeploy a container. That's a very slow process. That's going to slow down your development time. And what I'm going to do is I'm going to show you guys how we can work around that, because that's obviously not sustainable. You can't be rebuilding an image and rerunning a container every time you make one tiny change in your code. So what we're going to do is we're going to make use of something called, we're going to make use of volumes. So within Docker, we have volumes, which allows us to have persistent data in our containers. But there's a very specific type of volume called a bind mount in Docker. And this is a special volume because what it allows us to do is allows us to sync a folder in our local host machine, in my Windows machine in this case. It allows me to sync a folder or a file system to a folder within our Docker container. So what I can do is I can take all of these files and sync them into the /app directory of our container so that we don't have to continuously rebuild the image and to redeploy a container. Every time we make a change, it'll automatically sync those two for us to really speed up the development process. So let me show you guys how we can do that. So we're going to delete our container. All right, and what I'm going to do is we don't need to rebuild our image. The image is just fine. But I'm going to hit up a few times so we can get to this run command. So we're going to use the same exact run command. And we're going to pass in a new flag. Doesn't matter where you put it. And it's going to be the -v flag. So this stands for a volume. There's a couple of different volumes or different types of volumes, but remember, we're using the bind mount, which is a special volume that allows you to sync a folder from your local machine to a folder in your Docker container. And so the syntax for this is you do -v and then you specify the local folder or the path to the folder on your local machine. So I'll just say path to folder on local machine, on local, and then we do colon, and then we do path to folder on container. Okay. So kind of like pseudocode, just so you guys understand. So this is going to be the location of this folder, right? Because this is the folder that has all my source code, and I want to sync that to a folder within our Docker container. And that's going to be in the /app directory because that's where we're going to store all of our source code. So let's hard code those values. And so here, unfortunately, I can't just do a dot right here. It's not going to register that. It's not going to work. You have to actually pass in the whole path. So if you're using VS Code like I am, you can right click here and then just select copy path. And then you can right click and it's going to grab the entire path in my host machine to this folder. Obviously, I'm going to delete the Dockerfile section. We just need to get into the node docker, which is the name of the folder that houses all of my code. And then we do colon, and then we do the path to the folder in the container. So what folder do we want to copy it to? Easy. We want to copy it to /app. Right, and that's all you have to do. You hit enter and it's going to sync your code. However, I do want to show you a couple of shortcuts because that does look a little messy having to type all of this out. And so what we can do is we can make use of variables. And so I'm going to delete this. I'm going to show you guys what you can do instead of having to type out that whole nonsense. And it's going to be different based off your operating system. So if you're using Windows and you're using the command shell, then what we can do is we can type in %cd%. So that's going to grab the current working directory. So that way I don't have to copy that entire path. That only works on Windows command shell. If you're using Windows PowerShell, then you're going to have to type in $ curly braces, pwd, closing curly braces. That's going to grab the current working directory. And if you're on a Mac or a Linux, then you can type in $ parentheses, pwd, and then close parentheses. So that's just a shortcut, or you could type out the entire path. Whatever is easiest for you, feel free to do that. So I'm just going to use my %cd%. All right, and so let's hit enter. And depending on what operating system you use, if you're using Windows, anytime you're doing file sharing, you might get this warning. There's a couple of optimizations that you can make. I usually just ignore it for now. All right, so now theoretically, it should be syncing this entire folder with the /app directory in our container. And so let's minimize this. And let me just refresh this. So you can see right now, we've got the 4 exclamation points. Let's go back to our code. And I'm going to delete the exclamation points. All right, and then after we delete it, let's save it. And let's see if I refresh this page, does the changes take effect? So let's hit refresh. And it looks like it didn't. So do you guys know why it didn't take effect? Well, let's take a look, right? Because theoretically, this command, this flag right here should sync the folder. So we should see this file get synced to our container. So let's drop into our container and take a look at what the file looks like in the container to see if it actually updated. All right, because maybe I was lying to you guys and this does absolutely nothing and I wasted your time. So we log in. Let's do an ls. So we've got our index.js, and let's print out the contents of the file by typing in cat and then index.js. And if we take a look at that, we can see that, hey, look, it did actually sync our code. It deleted the 4 exclamation points. So why exactly did we not see the update in our web browser? Well, this is easy. For anyone that's ever worked with Express applications, I'm sure you might have an idea as to what exactly caused this problem. Remember, anytime we make changes to code in any Node or Express application, we have to restart the Node process. We did not restart the Node process. We just changed the code and we hoped that it would automatically work. But we had to restart the Node process. Right? And, we could go in, we can kill the Node process, start it again, but obviously that's inefficient, right? We already have a solution that we already know is going to work, and that is we're going to make use of NodeMon, right? NodeMon will always look at your code, and if any changes take place, it's going to restart the Node process so that the changes are updated in real time. So let's get that set up and installed. I'm going to exit out here, and we need to update our package.json file. So let's get NodeMon installed as a dev dependency. And I'm going to do this on my local machine just so that we can have it set up in this file. So I'm going to do an npm install nodemon -- save dev. So this is going to be a dev dependency just because we don't need it to run when we actually deploy to production. And remember, I'm just doing this on my local machine right now just so that we can update my package.json file. All right, so we've got our dev dependency. Now let's go to my package. Well, I'm already in my package.json, but let's set up a few scripts. So we'll do a start, and this will just be the usual node index.js. And then we'll have a dev, which is going to be, which is going to be a nodemon index.js. So by running nodemon in dev mode, it's going to automatically restart it's going to restart the node process anytime there's any changes to our source code. Now, as a heads up, when I was doing a dry run of this demo, I did run into some issues on specifically, it looks like Windows machines. So if you're on a Windows machine and for some reason later on in this video, you run into some issues with nodemon not actually restarting, you may need to pass in the -l flag. So that kind of fixed most of the issues. If you do run into the issue, just try the L flag. If you want to read up on it, just Google the error message that you get, or just Google nodemon not restarting on Windows for Docker, and they'll give you an explanation for why you need to pass in that flag. But I'm going to keep that in there because I'm running a Windows machine and I did run into that issue. So let's save all of that, and let me kill the Docker container that we have. So I think there should be one running. So we'll do a docker rm node-app-f. All right. So now that we made changes to our package.json, we're going to have to rebuild our image now. So we'll do a docker. Let me see if I have that command cache someplace. Here we go. Build. So we'll do the docker build. And notice how it's taking a little bit longer this time. And that's because our package.json file changed. So it had to rerun step 3, where we copy package.json, and then rerun step 4, and then rerun step 5, because we have to run all the steps after that, because we don't know if changes to this file changed any of the cache results. So that's why it took a little bit longer this time. But hopefully by now you guys get an understanding of how all the caching works in Docker. All right, so now let's redeploy. Actually, before we redeploy, there's a couple of things that we have to change. I realized I forgot to do this. So back in our Dockerfile, right, we're not going to run node index.js anymore. So in the development mode, we're actually going to run, if you take a look at our package.json, we're going to run npm run dev so we can run nodemon. So let's go back to our Dockerfile. We'll do npm run and then dev. Save that. Sorry about that, guys. We're going to have to rebuild our image again. So let's rebuild it. All right. And so now let's run a container from that image. And this time we want to do it with the bind mount again. Let's hit enter. We've got our Docker container. let's quickly test this out. Okay, so the exclamations are gone, which is fine. And let's make a quick change to our code. I'm going to re-add the exclamation points. Save it. All right, and if I hit refresh, look at that. So it looks like NodeMon's doing its job, and anytime we make changes to our code, it's automatically restarting the node process, and our bind mount is successfully syncing the code from our local machine to our Docker container. Now, I want to do a quick little test, and I'm going to do this because I suspect, depending on how you guys followed along to this video so far, you may have run into an issue in the most recent step. So let me delete my Docker container. So let's do a docker rm node-app-f. And what I'm going to do is I'm going to take this node modules folder on my local machine, which I don't need anymore because we're not developing on my local machine, and I'm just going to delete it. All right, so now that it's gone, I'm going to redeploy the container. I'm going to show you that we're going to break our application. So it's now running, and if I go to my web browser, hit refresh, you can see it spins and it's eventually going to crash. Let's give it a second. There you go. So what exactly happened? Well, let's take a look. So if I do a docker ps, let's see if my container's running. And look, that's the first issue. Why is our Docker container not even showing up on this? Well, when you do a docker ps, it's only going to show you running containers. So let's do a docker, I think it's ps minus af. Yep. So this is going to show you all containers started or stopped. And you can see our most recent container, our node app container, and it said it exited 30 seconds ago, which means usually if it automatically exited, it usually means something crashed. So if you want to take a look at the logs to see why something crashed, we can always do a docker logs, and then you specify the name of the container. So this is going to give you all the logs for that. And this is going to show us some node or nodemon logs. And you'll see right here, it says nodemon not found. So what exactly is happening? We know for a fact that nodemon should be installed because we had everything working before. The only change we made was we deleted the local node modules folder. Why should that impact anything? Because it was working before. Well, let me tell you what happened. So what happened was, we create our Docker image, right? Where we copy our package.json file, and then we run an npm install. So at this point, when we run npm install, it should install nodemon for us. And it is in there. But then we copy all of our files, which once again, not an issue actually. I don't know why I kind of made it seem like it was, but we copy all of our files, all of our source code, and then the command specified for the container is npm run dev. Now, when we go back to our Docker command that we used to actually create our container, we created a bind mount. So the bind mount syncs this folder with the /app folder. And this is where the issue occurred because it's syncing this folder. Since there's no more node modules folder in this folder, it syncs that with the /app folder. So it ends up overwriting the /app folder and deleting the node modules folder in the /app folder of our container because it doesn't exist in our local directory. And since we have a bind mount, it's going to sync those two directories together. That's the problem, right? Because once we deleted the node modules folder from our local machine, it will also delete it from our Docker container. And then without the node modules folder, that container has no idea what the hell nodemon is. So how do we get around this issue? How do we prevent our local directory, our local folder, from overwriting the /app directory and deleting the node modules folder? Well, there's a simple little hack that we can do, and that is we're going to create a new volume. And we're going to create a volume that's called, there's a couple different volumes, like I said in Docker. A bind mounts one, we also have an anonymous volume. And volumes work based off of specificity. So we've got a volume on our container for the /app directory, but we want to make sure that we preserve the /app/node modules. So we want to make sure this bind mount doesn't override the /node modules folder within the app directory. And the way we can do that is we could just specify another volume. So first of all, let me delete our broken container. All right, and then we'll run that same command, but I'm going to pass in another v flag for another volume. And I'm going to say this volume, which is going to be an anonymous volume, is going to be for the /app/node underscore modules. This is a little hack that you can do to prevent the bind mount from overriding the /app/node modules folder, because all volumes in Docker containers are based off of specificity. So even though this bind mount should sync with the /app directory, we can see that we have another volume that that references the /app/node modules folder. And you can see that since this is a longer path, that's basically more specific. So that's going to prevent this bind mount from deleting the node modules folder. Basically, this extra line is going to say, hey, don't touch this folder since it's a more specific, it's a longer path, it's more specific, so it overrides the bind mount. The bind mount will still sync all of the other files, it just cannot touch the node modules folder. All right, so now if we hit enter, let's do a docker ps, and it should stay running. Let's just make sure it didn't crash, and it looks like it didn't. So now if we go to the website, let's hit refresh, it's there. Let's make a few changes just to make sure nothing else broke. We'll delete the exclamation points, hit save, and then hit refresh, and it looks like everything's working. Everything looks perfect so far. Now, there's one thing I do want to point out. So you'll notice that we do a copy where we copy all of our files into our container at the build stage. And you might be wondering, well, do we really need to do that if we have our bind mount? And the thing is, the answer is yes, because the bind mount is really just for our development process. We only use the bind mount when we're developing because that's when we're changing our code. When we go to actually deploy in production, there obviously isn't going to be a bind mount because why are we changing our code in production? So we still need this copy command for when we deploy into production because there is no bind mount and we have to make sure all of our source code gets copied into the image for our production container. All right, guys, so when it comes to Docker volumes and bind mounts, I want to show you one last thing. We're going to make one slight change. Not required, but it's kind of best practice. So what I want to do is I have my container still running. If you don't, go ahead and just run this command again, where you have the bind mount and the anonymous volume. And I want to drop into bash so that we can take a look at the file system. So we'll docker exec-it app and then bash. All right, so we're in our container and let's do an ls. And so remember, since we have the bind mount, this directory is going to sync with the directory in our container. However, it's a two-way street. So if I make changes here, it's going to get updated here, right? If I do a new file and I'll just say my file, and I do an ls here, right, we can see my file. However, if I create a file within my container, it's going to add it to my local machine as well. So if you want to create a file, just for demonstration purposes, you can type in the command touch. It's going to create an empty file, and I'll just say test file. So if I do an ls, we created our test file, and you can see the file showed up on my local machine. I want you to think about a potential issue with that. Why is our Docker container changing our files? Is there ever a scenario where you want your Docker container to actually be making changes to your source code or any of the files associated with your source code? Probably not, right? It seems like almost like a security issue for it to even allow it to do that. Right? There may be certain instances where your application actually creates files on the local machine, and in that case, you might want to allow it. But for the most part, you don't want your Docker container being able to touch any of your files or make any changes to it because there's really no need to. And so what we can do is we can take our bind mount that we created and we can make it a read-only bind mount, which means the Docker container will be able to read any of the files, but it can't touch any of the files and it can't create any of the files, right? It's read-only. So let's get started on that. We'll exit out of here and I'm going to kill this container. And to make this a read-only bind mount, it's very easy. So let's run this command. Where'd it go? There we go. Let's run this. And all we have to do is specify colon at the end of /app. We do colon RO. And that implies read only. So we'll hit enter. Hopefully it's running. And we're going to go and drop into bash to our container. All right. And so now here, let's create a file. So we'll do touch, new file. And look at that. It says this is a read-only file system. It cannot make any changes. It cannot create any new files. It cannot edit any files. Everything is read-only. So this is a little bit of an enhancement that we can make so that it protects our source code and it doesn't allow our Docker container to do any kind of funny business with any of our source code. All right, so let's exit out of here. And I'm just going to do a little cleanup. I don't need these files. All right. And now what I want to do is I want to show you guys how we can start making use of environment variables within our Docker container. So if you go back to our index.js file and you remember our Express app, the port it's going to listen on is going to be based off of an environment variable called port that we pass in. If this variable is not set, it's going to default to a value of 3000. So how do we make use of environment variables within Docker containers? First of all, let's go to our Dockerfile. And we're going to specify a default value for our port variable. So after our copy command, doesn't technically matter where you put this, but we can say env. So this is referencing environment variables. We're going to create one called port. And we're going to say the default value for this environment variable is port 3000. And then we want to expose, remember, this is just merely for documentation purposes. This command doesn't really do anything. Instead of having to hard code 3000, what we can say is we can reference this port variable by passing in a $sign and the name of that variable is port. So if this gets updated, this will automatically get updated as well. So let's save that. And what we want to do is, let's see, do we have any containers running? Yep. So let's just kill that. All right. And let's rebuild our image because we made a change to our Docker file. And we can do a Docker build for that. All right. So now that those changes are made, our application shouldn't really fundamentally change because now we're just setting our environment variable to be port 3000. Before it was defaulting into a value of 3000, but now since the environment variable is set to 3000, everything should theoretically work the same. It's just now going through that environment variable. But what I want to do is when we actually deploy the container, we can specify what value we want that environment variable to be set because this is just the default value. We can always override it. So let's deploy a new container with the same exact command with both of our volumes, but we can pass in an environment variable by passing in --env, or you can just do a single dash and the letter E. So whichever you prefer. I don't know why I prefer the --env, but whatever you prefer. And then you pass in the name of the environment variable equals, and then whatever value you want it to be set to. So let's say we want our Express server to listen on port 4000. Now it's going to change to 4000. However, before we hit enter and actually create our container, remember, since our Express application is listening on 4000, we have to change the port that we're sending traffic to. Because right now we're sending traffic to our container on port 3000, but our Express app is listening on port 4000. So we have to change this to 4000 or then our application is going to break. We don't need to change the port that we have to hit on our local machine. We could technically change it to 4000, but it doesn't really matter. You can pick any value really here. So let's hit enter. And let me just make sure it's running. All right, so it's running. So now if I go to the web browser, hit refresh, it looks like it's working. Just to double check everything's working fine, let's just make a few changes to add the exclamation points back. Save, hit refresh. It looks like everything's working. Just to double check, I do want to make sure that the environment variable did get set. So we can drop back into that container again like we always do. Where's that command? Docker exec. So in a Linux machine, if you want to ever see the environment variables, you just type in print env. And so here we can see that the environment variable of port equals 4000 was set. And so that confirms that when we ran our docker run command and passed in the --env flag, we were successfully able to overwrite the port variable or the port environment variable that was specified in our Docker file. Now, when it comes to your application, you may have more than one environment variable. Actually, you most certainly will. And if you have a lot of environment variables, you can pass in the --env flag as many times as you want. So if you wanted to, you can say where'd it go? Here we go. So if you wanted to pass in another one, you can just do --env and then whatever that variable is. However, if you've got like 10, 20 environment variables, that's kind of a little bit of an exhausting process. And it's a little bit of a pain. And so what you can do instead is we can actually create a file that stores all of our environment variables. So here I'm going to call this, you can call it whatever you want, but standard convention is .env. And here we can just specify port equals 4000. Right, and so that's going to essentially do the same thing. And here you could just provide a list of all of your environment variables. And let's save that. And I'm going to kill my Docker container real quick. Right, and so now if you want to load environment variables from a file instead of having to pass each one line by line, let's go to that Docker run command and we can remove the --env. And we can pass in -env-file, and then the path to our environment variable. So from our local directory, we do // and then .env. And so that's going to grab this environment variable file and then all of the environment variables stored in here. I think I saved it. Yep. And let's hit enter. Hopefully this works. Let's go Docker PS. All right, it's running. I'm going to log into the container and do a print env. Let's just make sure that it's set, and it looks like it's set. So those are the two different ways to specify an environment variable and to set environment variables for your Docker container so that your application can get the necessary data that it needs. Now, one thing I want to point out is as you've been creating Docker containers and deleting them, if we do a Docker PS, you'll see that we just have one container running. If you do a Docker volume ls, this is going to list all the volumes that you have. And you can see that we've kind of built up a couple of different volumes. And you might be wondering, what are these from and why are they building up? And as you keep creating containers and deleting containers, they're going to slowly build up over and over, and you'll eventually end up with hundreds. And the reason for that is if you take a look at the command that we're running for our Docker container, this volume that we specified right here for the /app/node modules hack, this is an anonymous volume. So every time you delete your container, it's going to preserve that node modules folder in here. And we don't actually need to preserve it, right? Because we're going to be deleting and creating new containers all the time. So you can go in and manually delete the volumes, right? You can always do a Docker volume rm and then specify the volume name, or you can do a Docker volume prune that should remove all unnecessary volumes. But if you want to make sure that these volumes don't build up, usually what I like to do is when you do the Docker rm command, it's not going to delete the volumes associated with that container. So if you want to delete the volumes, which in our case we do, there's obviously plenty of instances where you don't want to delete the volumes because the whole idea behind a volume is that it's persistent data. You want to preserve it. So like if you have a Postgres database or a SQL database, right, you want to preserve all your database records. So you would never want to delete that. But in our case, we just have an anonymous volume so that we can get around that limitation that we ran into before. So when you delete a container, just pass in the -v flag. When you pass in the -v flag, it'll make sure to delete the volume that's associated with that container so that it doesn't build up. So for now, I'm just going to do a Docker volume. I think prune should work. It's going to say hit yes. Let's see if I do a Docker volume ls. You can see that it's deleted all but one, and this is the volume that's associated with the container still running. So if you want to do the Docker, that little trick I just showed you with the running container, where is that? Here we go, -fv. It's going to delete the container, and it's also going to delete the volume as well. So moving forward, do the -f and then v so that you can delete the volume as well. So now when it comes to creating our container, we've kind of set up a nice little quick workflow for developing a Node or Express application in a Docker container. However, the command to run the Docker container, this command right here, is kind of long. And I don't want to have to rerun this command every single time I want to get my container up and running. Although I'm sure you're thinking, well, you could just hit the up arrow key, so it's not a big deal. And that is 100% true. However, keep in mind when you're actually developing, like an Express application or some kind of Node application, you're probably going to have more than one Docker container, right? Right now, we're just building the Express server, but in a full-blown application, you might have a container for your database. You might have an Elasticsearch container, you might have another container for Redis. You're going to have multiple containers, right? And each one of those containers, you're going to have to run a command that's this long or potentially as long. And at that point, it starts to become a real hassle of getting your entire development environment up and running, and even getting your production environment up and running, because you're going to have to run 5 or 6 Docker commands. And you have to make sure there's no typos or anything like that. So what I'm going to show you guys is a way we can kind of automate all of these steps so that we don't have to run this monstrosity of command. And we're going to use a feature called Docker Compose, where we can create a file that has all the steps and all of the configuration settings we want for each Docker container. So we can say like, hey, I want to create a node container using the image that I created, and I want to create a volume for the bind mount, and I want to create an anonymous volume. I want to pass in the environment files, and I want to open up these ports. So you can pass in all of these steps into a file, and then you can just run one very simple command to bring up, as many containers as you want. So if you have like 6 or 7 different containers in your development environment, you can bring up all 6 or 7 all at once with one command and bring them all down with one command. So let me show you guys how to do that. So what we're going to do is we're going to create a Docker Compose file. And so what we're going to do is we're going to do a new file. We're going to call this docker-compose.yml. So that stands for YAML. It's a certain type of syntax that you use. So what we want to do is, with your Docker Compose file, the first thing we have to do is specify the version that we're going to use. Now, if you go to this website right here, it's going to show you all the different versions of Docker Compose and the features that they support. Now, we're not going to do anything crazy, so I'm just going to use version 3, but if there's a specific feature that you need, then you're going to have to make sure you grab the specific version. This web page has a list of all the features that each version supports. So you can just take a look at this page and see what's the minimum version that you need to actually run all the specific features that you want. But I just default to version 3, so we'll say version, and then 3. Now, the next thing we want to do is we want to specify all of the containers that we want to create. And so within our Docker Compose file, each container is referred to as a service. So we do services, and then we just specify all of our services. Now, this is very important. With YAML files, spacing matters. Okay, so we're going under services, and we're going to provide a list of all the different services that we want. So I want you to hit tab just once. And then here we're going to provide our container, or our first container. In our example, we just have one container, which is our Node app. And we want to give this container a specific name. You can call it whatever you want. We can say like, oh, my Node app, or we can call this Node project, whatever you want. Just give it a name. I'm going to call this Node app because that's what it is. And then colon, and then we're going to add in specific configuration settings for that container. So because we're going to do configurations for that container, I want you to hit one tab, and then I want you to start adding in the different configuration settings. So the spacing matters, unfortunately. So if I start moving things around, it's going to break things. So you want to do one space for each level. And keep in mind, if you have multiple containers, let's say you have a Postgres container, you would add a Postgres service. If you had a Redis service, you'd add one here. So this is how you add more containers or more services within a Docker Compose file. We just have one, so I'm going to delete these. Now, under Node-app, we have to specify a build setting. So what image are we going to use? Well, we have to build the current Dockerfile in our current directory. So we can say build, right? And then we pass in the path to our Dockerfile. So it's going to be our current directory, or whatever directory this Docker Compose file is. So this is just automating the Docker build command so that we don't actually have to do it. Docker Compose will do it for us. We just have to pass in the path to the Dockerfile. A couple other settings. Let me actually just hit the up arrow key to see all of the different options that we have. So we do need to expose a port. So let's open up a port so we can pass in the ports option. So under ports, one tab, remember. And here we can provide a list of ports we want to open. So for our container, we've only been opening up one port, but theoretically you can open as many ports as you want. You do a dash because it's going to be a list of ports. And then here we're just going to do 3000, 3000. You already know what that means. I'm not going to rehash that. If you wanted to add another port, or open up another port, you can do that. So you can do like 4000 colon 4000 as well, but we're just going to open up one port. So I'll delete that. Now I'm going to hit backspace again. So we're lined up with build and ports because once again, we're still under the Node app service. And here we want to pass in all of our volumes. So we'll do volumes. And we're going to pass in our 2 volumes. And once again, this is going to be a list. So I want you to hit tab just once. And then we're going to pass in a dash. So the dash signifies a list. So the first one is going to be our bind mount. And the great part about this is that when you use a Docker compose file, we can just do the dot syntax. We don't need to use this variables that I mentioned before. So we can just do dot slash colon and then slash app. And I think you can pass in RO if you want to be read only. I don't really care. Right. And then we need to pass in our anonymous volume, right? Which is this one right here. And that's that little hack that we did to make sure that we didn't overwrite our node modules folder. So we'll do slash app slash node underscore modules. And then last but not least, I'm going to add my environment variable. Doesn't really matter where you put it. So once again, line it up with build ports and volume. So we do environment. And we say dash. And then here you provide a list of environment variables. So we can do port equals 3000. All right. Keep in mind, in this case, this would be like the equivalent of running the environment variables one at a time. So let me see if I can find an example. So like this. However, we can pass in a file like we did down here if you want, so that we can use the .env file. And the way to do that would be, let me see, you can go down here and we can say env underscore file colon, and then we can say dash, you can provide a list of files and then the path to the .env file. So whichever syntax you prefer, I'm just going to comment this out. I'm just going to use this because we just have one environment variable, so there's no need to import it in from an environment variable file. All right, so let's hit save. This has all of the settings that we need for our Node app service. And once again, you know, if you're building a full-blown project, you're going to have multiple services. So you're going to see how this kind of really simplifies the entire process of getting your entire development set up and up and running, and as well as tearing it down all within one command. So make sure you save that. And what we want to do is we're going to run the command docker compose. So we do docker dash compose. This is important, right? Don't do docker space compose. It's a different command. We want docker dash compose. And then we want up. So that's going to bring up everything that's in our compose file. And then one important flag is if we do dash dash help, let's see what options we have. We do have a -d flag, right? If you remember when we run our containers, we have to pass in the /d flag, or then we'll automatically attach to our containers, which we generally don't want. So we can pass in the same thing for our Docker compose. So we can do Docker compose up -d. So let's see if that works. So first thing you're seeing is that it's actually building our image. And so it's running, looks like I ran into, wait, yep, that's just a warning. Don't worry about that. I think that's a, new patch. So that's just a vulnerability message. Don't worry about that. So it built our image. If we do a Docker image ls, you'll see that this is the image that it built. And notice the naming convention. What it does is it grabs the project directory, which I called node-docker, and then it passes underscore and then node/app. So the node/app is from the service name. So it took the project folder, did underscore, and then the service name. If we had one for Postgres, it'd be underscore Postgres or whatever we called it. All right, so it built the image, and then it also started our container. So if we do a docker ps, right, you can now see that we have one container running. And it called it, once again, take a look at the name, node-docker, which is the project name, underscore, then the name of the service, and then there's an underscore 1. I think if you have multiple, if you spin up multiple Node app services, I think it goes like 1, 2, and 3. I think that's why the 1 gets appended. But let's test this out. Let's just see if everything works. So going back here, if I hit refresh, looks like it works. And let's change our code. And delete the exclamation points just to make sure it updates. Hopefully it works. And it looks like that, guys. Everything works perfectly. So hopefully you guys can see how easy it is now to actually bring up our entire Docker environment with just one simple command. And bringing it up is just as easy as bringing it down. So now if you want to tear down everything, we can do, let's see, we just do docker-compose instead of up. I'm sure you can guess what the command is. It's just down. And just like when it comes to deleting Docker containers, by default, it will not delete those anonymous volumes. So if you want to delete the anonymous volumes with the Docker compose down, we can do a -v, and that's going to delete all the unnecessary volumes that it creates. So we'll do -v. And you can see it's stopping the Docker container. It's then removing it. Technically, when you run Docker Compose, it creates a brand new network for all of your services. Don't worry about that. It's kind of outside of the scope of this video. But it does automatically create its own separate network so that it doesn't interfere with any of your other Docker containers. And you do get some extra features and perks when it comes to having a custom network like DNS so that you can reference names within your project. But don't worry about that for now. So now if we do a Docker PS, you can see that the container is deleted and everything's cleaned up for you. That's right, one command and you can start and stop theoretically hundreds of containers, right? Now, there is one thing I want to tell you guys. When we run the Docker compose up command again, what do you think is going to happen, right? Because if you take a look at the steps that took place when we ran it the first time, you can see it builds the image, right? It builds the image and then it starts the container. Now, if we run this again, I want you to tell me what you think is going to happen, right? Your natural guess is going to be that it's going to build the image again, and then it's going to run the container. Well, let's figure that out. Let's see what actually happens. If I run it again, look at this. The result was much quicker, and that's because it skipped the entire build process. It didn't build a brand new image. All it did was it created the network. I did tell you it created a network, and then it started our container. And the reason for that is that what Docker Compose does is it looks for an image. So if I do Docker image ls, it looks for that image based off of the syntax that I told you, which is project directory, and then the name of the service. And if it sees that that image already exists, it's not going to rebuild it. However, even if we make a change, right? Let's say we change the default port to be 4000. Oops. Right? This theoretically is now a different. It's a different image, right? We've changed something fundamentally in the Dockerfile, so it should rebuild the image if we run it again. So let me tear it down again. Let's do a Docker compose down. All right, and I think I saved it. I can never remember if I do that. And let's do a Docker compose up. So let's see if it rebuilds the image. And despite the fact that we made changes, it did not rebuild the image. So now we're essentially running a stale image, right? Why is it doing that? Like I said, there's just a simple dumb check that Docker Compose does. All it does is just look for an image named this. So if we do Docker image ls, we can see there's an image there. It has no idea that this is a stale image and that there's been an update. It doesn't know. Docker Compose is pretty dumb. It has no idea. So you have to basically tell it like, listen, I've made a change. I want you to rebuild the image. So how do we do that? Well, first of all, let me tear things down again. And let's go back to the Docker compose up command and let's do a -- help. And there should be an option that causes it to force a build. And let me see if I can find it. Here we go, -- build. So this, when you run the -- build flag, it's going to tell Docker Compose to rebuild the image. Docker Compose is not smart. It does not know when it needs to rebuild the image. You need to tell it to. All right, so let's rerun this again. We'll do Docker Compose up -d -- build. This will force a brand new build. And there you go. So now we built a new image. Now it created everything and everything should be working now. All right, so we can tear that back down. We can tear that back down. Change the default port to 3000. Save that, just so that we don't break anything else. And then if you want to, you can rebuild it again with the -- build flag. And so this will bring everything back up. and rebuild it with the new default port. And everything should be working. So let's just double check. And yeah, everything's working. Perfect. But that's the idea behind Docker Compose. There's nothing too fancy about it. Obviously, you're going to have to take a look at the documentation to see other things, because eventually when you get a little bit more familiar with Docker and there's other settings or options or flags that you want to pass in, you're going to have to update the Docker Compose file to take in those parameters. So I just covered the basic parameters, but there's obviously plenty more within the Docker universe. Now, we're almost done. However, there's kind of one last thing. This is kind of a big thing, but you may have noticed that we're running npm run dev, right? So how do we actually go into production, right? Because right now when we run Docker Compose, everything is with respect to our development environment, because our Docker Compose, it creates that bind mount, which we would never want in production deployment, right? We don't need it to sync with anything. It's our production deployment, right? And our production deployment might actually use a different variable or a different port that Express listens on, or it could use the same one. I don't actually know. It's going to depend on your company or how you set up your project. But mainly also within our Dockerfile, it's not going to run npm run dev. Instead, it's going to run either, where's my package.json? It's going to run an npm start, or we can just run node index.js directly. So in the next section, I'm going to show you guys how we can set up our Docker Compose file so that we can have a separate set of commands for production and a separate set of commands for development. All right, guys, so this is going to be the last section of the video, and this is going to just round out the entire project. I'm going to show you guys how you can set it up so that you can deploy your Docker containers to both a development environment as well as a production environment, because there are going to be some differences between those two environments. And the easiest solution is, you can obviously have a separate, you can create multiple Docker files. There's no rule against it. So you can have one Docker file for development, one Docker file for production, and then you can basically change out what you want. So really the main change in our case is just the final command that we run, npm run dev for development and npm start or node index.js for production, depending on which one you want to use. If you read online, some people recommend not using the npm command within container because it's just another layer between node and the container. So a lot of the times for production especially, you might want to just run node index.js instead of running npm start. But I think different people have different opinions on that. So we can create different Docker files. And on top of that, we can also create different Docker Compose files. So you could have one for production and you can have one for development. There's also differing opinions on that. Some people like to condense as much into a single file and be able to kind of run both of them off of one file, but it really comes down to personal preference. So what I'm going to do is I'm going to show you guys how to do everything as much in one file as possible. So we're going to use only one Docker file, but we are going to split up the Docker Compose files into two different files. Because showing you how to do it with two different Docker files, it's pretty easy, right? You just create two different Docker files and then reference them when you actually run the build command. So there's nothing really to that, but I do want to show you how to do it with one file, just in case you want to know that, because it was a little bit trickier. We do create like a custom bash script that actually handles that. So let me walk you through that. So what we're going to do is I'm going to rename this Docker Compose file just so that we have this for reference, but we're not going to use this anymore. I'm just going to rename it as backup or something, dockercompose.backup.yaml. And we're going to create a brand new Docker file, a brand new Docker Compose file. And on top of that, I'm going to create two more files. So let's do a new file. I'm going to call this one docker-compose.dev.yaml. So this is going to have the configuration specifically for our development environment. And then we're going to create one more. And I'm going to call this docker-compose.prod.yaml. So this is going to have all the configurations specific to our production environment. And remember, we're just going to have one Docker file. All right, so we have three Docker Compose files. And obviously, if you have like a staging environment, you can also create another one for that. Sorry, these are the three. This is the backup just for reference if you guys want to take a look at that later. But these are the three. So the Docker Compose file now is going to have any configurations that are shared between both environments. And what I mean by that is that, like I said, in an actual project, you're going to have 6, 7, 10. You might have a ton of containers. So you'll see that a lot of the configurations for your containers are going to be the same regardless of environment. So there's no point in us copying and repeating all of those configurations across both of these files. We're going to create a shared one for all the configs that will be shared between both environments. So what I'm going to do is I'm going to do the same thing. We're going to set the version like we normally do. And then here, services, we got our Node-app. And I forgot to add that tab. Remember, spaces matter in YAML. Right? And we're going to set the build to be the current directory like we did before. And then for my production and for my development environment, I'm just going to say they're both going to be listening on port 3000. However, keep in mind that maybe in your environment, they're different. So if they're different, you don't want to put in this file because this file is only for when things are the same between your production and your development. If they're different, you're going to want to put them in their respective files. This is only for shared configurations where they're the same in both environments. So ports, we'll set that equal to 3000 colon 3000 like we always have. And then we'll also set an environment variable to be port 3000. All right, so this is the only configuration that's shared between both. All right, so our development, our production environment, basically we're saying that the final image is going to be the same, ultimately, that we build from our Dockerfile, because both the environments are going to use the same Dockerfile. The ports are going to be shared, so we're going to use port 3000, and this environment variable that we're setting is going to be shared between both environments. All right, so now within our dev and our prod file, we can actually go into our services, create a Node app section, and then overwrite anything that we wanted to. So we could technically overwrite the ports, we can add in extra configurations and so on. So let's go to our dev environment. And I'm actually going to go back to this, and I'm just going to copy up to Node app because it's going to be the same. So we go into our dev and our Node app, and I'm going to set the volumes, right? Because in our development environment, we want our bind mounts, as well as the extra anonymous volume for making sure our node modules folder doesn't get deleted. So I'll do volume. And we're going to do / actually, why waste my time retyping that? We can just copy this from here. You just got to make sure the spacing's okay. Don't mess up the spacings. And I think I messed it up. Hold on, let's see. So yeah, 1 tab. And 1 tab. There we go. All right. And since this is our development environment, we're going to pass in an environment variable. Did I spell that right? That does not look right. There we go. And we'll say node_env. So this is just common across Node applications where in your development environment, you're just going to set this to development, and then in your production, you would set it up. You would set it equal to production. All right, and then the final thing is, in our Dockerfile, I'm going to change this to default to. It doesn't really matter what we set here because we're going to overwrite it. So I'll just set this to either npm start or node index.js, whatever you prefer. I'm just going to set this to index.js by default. And remember, we can override any of this in our Docker compose file. So in here, we can override that command with the command option. And we can say npm. Well, we do this on the same line. npm run dev, right? Because we have that script that's going to run nodemon so that it restarts our code in our development environment. Let's save that, or save everything. And now let's move on to our compose prod file, but copy the first 3 lines as usual. Now in our prod file, what do we need to exactly change? Well, let's take a look. We don't, in our development environment, we had our volumes. We don't actually need these. The only thing I can think of is we need to change the environment variable to be production, and we need to change the command to be either node index.js or npm start. depending on what you prefer. So let's add those in. So we'll do environment. And then we'll do node_env equals production. And then our command is going to be set to node index.js. Once again, you can do npm start, whatever you prefer. So that's pretty much what we need. So let's test this out. I'm assuming I've probably put in a couple of typos, so we're probably going to have to do a little bit of debugging. All right, so what we want to do is the command's going to be a little different. So first of all, do I have anything running? Yeah, I do. So let's do a docker compose down-v to delete everything. So docker ps, docker images. All right, so now how do we actually run this now that we are going to have to run two Docker compose files, right? Because when we want to run in production, we're going to do the base Docker compose plus the dev. And then when we want to work in production, we do the base plus the prod. Well, what we have to do is you do docker-compose, and then you pass in the -f flag for file. And this is important. The order actually does matter. So the first file that we want to pass in is the base file. So we do docker-compose, compose.yaml. Then we pass in the -f flag again to specify the second file. So if we want to go into development, we're going to pass in the docker-compose.dev.yaml. Right? And so what's going to happen is it's going to load all the configuration from the base file, and then it's going to load all the configuration from the dev file, and then if it needs to, it'll overwrite any of the configurations that it's been set to from the base, and that's why we pass it in that order. Right? And then we want to say we want to bring it up, and then remember we want to run it in detached mode. So let's test this out. Hopefully this works. What did I mess up? Docker dev.yaml. What did I mess up? Must be a mapping, not an array. Let's see. Oh yeah. Look, I mean, you can see I already messed the indentation. The volume, environment, and command need to be under the node app section. So that's what broke. So let's tab everything up one section. And now let's give that a shot. All right, looks like things are working. So hopefully, yep, everything looks good. So let's just do a docker ps, and we see our container running. Let's go to our application. Let's hit refresh. It looks like it's working. Let's just go to our code, make a few changes to make sure that things are updating and that NodeMon's doing its job. So let's hit save. Let's go back, hit refresh. Look at that. So this is our development environment, and it looks like everything's working perfectly. And we can go ahead and shut that down. So we'll do, remember, same thing, we do down, and we can pass in the -v flag so we can delete those extra volumes. And it should stop it. Now let's do the same thing. We'll run that same up command, but instead of running docker compose.dev, let's try the prod version now. All right, and it should be the same exact command outside of specifying the prod.yaml file. So we hit enter. Perfect. Let's hit refresh. All right, so there's no exclamation. That's just because we didn't rebuild the image, but we'll go over that. But let's just try to change things. Well, I guess there's no exclamation at the moment, so let's hit save. And let's see if it changes. And it looks like it doesn't, which is perfect. Right? We don't want any changes. We add anything else here and then hit save. Remember, we're in production, so there is no bind mount and we shouldn't see any changes. Now, just to make sure things are working, I'm going to bring this down. We're going to do a down -v. And just like before, right, when we make changes to anything, like our source code or anything else, since we're in production environment and there's no bind mount, anytime we make changes to our code, we're going to have to rebuild our image. And we have to tell Docker Compose that we want to rebuild it. So we'll do up. So right now it's got all this nonsense in there. So we do up, -d, and then I think it's --build. It's going to force a new build, right? Because now we're changing our code. There's no bind mount. And so to actually see the update, we have to rebuild the image. All right. And so now if I hit refresh, we see all of that nonsense. And just as a double check, let's delete the exclamations and let's delete all that nonsense right there. Hit save. Do we see any changes? Absolutely not, because remember, we are in production environment. So this confirms that we now have set up different Docker Compose file for our production environment and for our development environment to accommodate our specific needs for each environment. Now, there is one last thing we got to do because there's a little bit of an issue, and I'll show you why. Right now, what was the last command? We're running in production mode, right? So we ran the docker compose.prod, and I'm going to do a docker ps. Let's just quickly get the name of that Docker image, and I'm going to connect to this Docker container. So we'll do docker exec-it, and I'm going to copy that name, and then we'll do bash. All right, so here, what I'm going to do is, well, first of all, you'll notice that we copied a whole bunch of Docker Compose files. And that's because in our Dockerignore, they're not in there. So we can add those in there as well. And we can just say docker-compose star. And that'll just ensure we don't copy anything or any file that starts with a docker-compose. So this is kind of a wildcard for matching anything after that. So we'll hit save on that. But that wasn't really the main thing I wanted to address, actually. So if we go into our node modules folder, this is kind of important. If I do an ls, this is going to show you all of the dependencies that we have, all the packages. And there's something very important. If you look at this, you can see that nodemon is installed. And you might be wondering, why is that an issue? And I want you to remember, we are in production mode, right? And in our package.json, we can clearly see that nodemon is a dev dependency. We don't need this when we run into production mode because we're never going to be using nodemon in production. That's only for development so that it automatically restarts the node process when we are developing our project. So how do we actually prevent nodemon and any other development dependency from getting installed? Because right now it's just taking up space and doing absolutely nothing. Well, in our Dockerfile, you can see that we run an npm install. If you want to actually deploy this to production, right, you would normally run a I think it's a -- only equals production, right? And so that'll prevent any dev dependencies from getting installed because you're running in production mode. So what we have to do now is set up our Dockerfile to be intelligent enough to know whether we are in development mode or production mode, and then either run an npm install or an npm install -- only equals production, depending on if we are in our development or if we're in our production environment. So how exactly do we do that? Well, we're going to have to basically write an embedded bash script. So here, instead of this line right here, what we're going to do is I'm just going to go under here, and we're going to replace it with this. I'm going to say run, and we're going to do an if statement. And we're going to say if, and then we're going to do brackets. And this is important. Make sure you hit one space. All right, this gave me all sorts of issues. You want to make sure you put that space. And then in quotations, we'll do $node_env. And then that equals development. Right, and this is also important. Hit one space afterwards. I don't know why it required that, but it did. And I was troubleshooting that for a while. So make sure you get the spaces just right. So what we're saying is, if we are in a development environment, then we want to run an npm install. However, we're going to do an else if we're not in development. So we're in production, we're going to do npm install -- only equals production. All right. And then we end that if statement. And we no longer need this run command. Okay, so basically, we're referencing some kind of variable here called Node.env. And then when it's set to development, we'll do an npm install, or else we'll do an npm install with -- only equals production. Now, what exactly is this? Well, this is an argument that we have to pass in. So here we do arg node_env. So this is an argument that gets passed into our Docker file when it's building the Docker image. And we have to set this value in our Docker Compose file. So under dockercompose.dev and .prod, we're going to have to pass that in. So going to the .dev file, we are going to actually overwrite something in our base Docker Compose file. So instead of doing just build that, we're going to have to change this up a little bit. So here, when we do the build command, we're going to override that. And instead of just doing dot, instead of just doing colon dot, we can actually break this down into a few more settings. We can do build colon and then pass in two properties. We've got the context and then we've got the args. Now the context, remember when we did build dot, and that's just specifying the location of the Dockerfile? That's what the context is. So here we just specify the location of the Dockerfile, which is in the same directory. So we just pass in dot once again. And then here under args, we pass in all the different arguments that we want to pass. So here, the only thing we care about, right, is the one that this Dockerfile is using, and it's called node_env. So we do node_env, and we're going to set this to development because we're in the development Docker compose file. And we're going to copy this, and I'm going to do the same exact thing in my prod file. And we're going to space that. There we go. I think that should be good. Yep. And we're just going to change this to production. And let's save everything. And let's just do, I'm going to bring this down. All right, and let's just make sure we save everything again. All right, so now it should theoretically, run this if statement when we want to do an npm install, and it should be able to detect depending on what the arguments that's passed in. So we're going to run in development mode first, just to make sure everything's working, and then we're going to run it in production mode after that, just to make sure that that actually made the changes that we wanted. So let's go back to my up command. We're going to start off with dev. All right, so it's building that. Remember, I told it, I passed in the -- build flag because we made changes, and Docker Compose is not intelligent, and it will not know that we need to actually rebuild it. So I always pass in the - build flag in that scenario. And let's test this out. So hit refresh, it just says hi there, which is fine. When we go to our index.js, let's add some exclamation points, hit save, refresh, perfect. So just the fact that it restarted automatically and it adopted those changes, we know that nodemon was successfully installed. And so we know that that if statement so far, right here, it ran an npm install because it detected that we were in development mode. So far everything's looking good. Let's bring everything down. With the -v flag, let's delete that volume. And this time we're going to bring it back up, but I'm going to do it in prod. All right, and let's just do a docker ps, just make sure everything's running. Perfect. Let's hit refresh. Perfect. Let me make changes to this code real quick just to make sure it doesn't adopt those changes. So we'll hit save. Let's hit refresh. No changes. Perfect. The last thing that we want to do is let's log into the container and let's just make sure it did not install nodemon, just to ensure that it did successfully run the -- only production flag. So we'll do docker exec -it. And then bash. Right, ls, let's go into node modules. Also notice how our Dockerignore file worked this time because it did not import any of the Docker compose files. But let's go into the node modules folder. Let's do an ls. Do you guys see anything with nodemon? It should be alphabetical. Let's do it. All right, so if we go to m, n, see, nothing with nodemon. So it successfully is in production mode. And if you do a print nv, we can see that I would have thought we would have set node env set to production too. So everything looks like it's working. It successfully only installed all of our production dependencies. And so guys, that's all I wanted to show you. It's just a matter of 2 commands. Whoops. Well, it looks like we're not actually going to get out of the container, but it's just 2 commands, right? So you do docker compose up, docker compose down. And then if you're in production, you pass in the prod. If you're in development, you pass in dev. That's all you have to do. You've got 2 different environments, and we can easily spin up all of our containers and then also spin them back down with just 2 simple commands. So hopefully you guys enjoyed this video. If you guys want me to show you guys how to kind of build a actual full CI/CD pipeline, let me know, and I can set up a follow-up video explaining how we can do that using GitHub Actions.